Alright, so here's my code for my numerical calculation standard. This is my first time actually using VPython. I actually prefer to use GlowScript, is what I just found out, because GlowScript, you don't have to download it to your computer, and it's a lot easier. And besides, you get to hold all your programs in one place. You don't have to worry about actually storing them on your computer. It's actually better to keep them online because you can access it from anywhere, while my VPython program, you have to save on a flash drive. You have to save it to the hard drive of your computer. But basically, this is my code. It's on VPython. I'm just kind of walk through it. This is my first time actually using VPython, so that's kind of like the reason for all the comments, comments all throughout that. I'm pretty sure someone who's more experienced with computer programming or, just any kind of coding like this wouldn't need all these comments. So, but basically, I'm just, I wanted to show the electric field due to a proton, and I wanted to show basically it's the force felt by another charge in in the vicinity of the proton. So yeah, basically I started off with my constants, oof pairs. That's basically that's just code for 1/4 pi epsilon naught, and then basically that's what this is right here. Q proton, that's just the charge of a proton, which is 1.6 times 10 to the negative 19. The scale factor, basically that's just something that I use in my coding that I had to actually to kind of make it make sense, because otherwise everything would have been all out of proportion. That's what I got right here. Alright, so I started off with this. These are my actual visual objects. So basically I have my proton, which is equal to just a sphere. I had to give it a position, radius, color. I actually wanted to make this equal like the Earth. This is something you showed in class, where you showed you can make a proton, give it a pattern where it equal to Earth, but I didn't get around to doing that. Basically I gave this is the observation location. Basically that's where we're calculating the E field at. So basically that's like me placing another proton there and seeing what the force on that proton is. So that's what this observation location is. Our arrow, that's just like an arrow showing the direction of the electric field to the observation location, or basically to wherever I want to place that other proton. I went on next to show my important variables. This is basically my observation location. That's see, earlier I said this is my observation location. This is actually the dot that I'm placing at my observation location. This is my actual observation location, which I had to give it a vector. Yes. And then basically I just had my calculations right here. RP. Oh yeah, this is my relative position vector from proton to the observation location. And then, so basically that's just the vector from my initial proton here to the observation location that I want to calculate the electric field at. Relative magnitude of relative position vector, that's basically just my magnitude. R hat, that's just direction. So R hat is just equal to the magnitude of relative position vector divided, it's just going to equal to the relative position vector divided by the magnitude of that. And then EP, that's my electric field from my proton. So that's 1/4 pi epsilon naught times the charge of the proton divided by the relative position magnitude squared times R hat, and that's just my direction. So here I tell VPython to print out my RMag, and and then I tell it to print out, these is just actually telling it to print out the variables, well, they have to print out the actual calculations. So yeah. And here I give my basically my arrow showing it. I give my arrow have multiplied times the scale factor so everything can make sense. And then I turn it to the color orange. So I'm just gonna run my program, show that it works. Alright, bam, here we go. So with VPython, just like GlowScript, you can you can rotate it, you can zoom in and out. So yeah, so basically this is right here, this is my proton. This is showing This is my relative position vector, and this is just my E field on my new proton, which is located somewhere, well, at my observation location, which is located somewhere here. So this is just the direction from my proton showing to my observation location, basically just showing the E field, and this is basically like a representation of the E field at my observation location. And yeah, that's pretty much it. I'm gonna work on a better code in GlowScript to, for my video reassessment, but this is just something to get me started. All right.